current is the flow of charges. Basically, it is the rate of flow of charge. Okay, it is the rate of flow of charges. How can we imagine this term? Like if we take a conductor like this, like let us assume this is the wire that we have in our like connections at home. So if some charge is being flowed through this wire, let's say delta Q, and the time taken for this charge to reach from this point A to this point B is delta T, then the current flown will be delta Q over delta T. Okay, so before this thing I'll be making you familiar with the two more terms, that is types of current. And the types of current, we have two types of current, not a very big concept, just small concept. First is average current and instantaneous current. Okay. Basically, average current is the current over a fixed like a period of time, and this period of time is significant. And instantaneous current is a current that we take on a just instant of time. Okay, it is for a significant period of time. Period of time. This is at an instant. Okay. So here, what I found out here, this is actually the average current. Why? Because we are taking a span of time, that is delta T. Okay, this is average current. So let me give you an example of the average current. Suppose the current or the net charge flown through this like a particular wire that we take in this example is, let's say, 2 coulomb. We already know that coulomb is the unit of charge, and the time taken, that is delta T, is, let's say, 4 seconds. Okay, so the average current that will be flown through this wire will be 2 by 4, that is 0.5 ampere. Ampere is the unit of current. Okay, so unit of current, or I would say the SI unit of current, that you can also note down, is ampere, that is named after a scientist. Okay, so we have got to know what is the meaning of average current. So for instantaneous current, we have to do nothing. We have to take the instant. And how do we take the instant? We just shrink the time interval. Okay, so how do we do it? For instantaneous current, what I'll do it, I'll just shrink the time interval. I'll do it like I'll take delta T tends to 0. Okay, instantaneous current will be this, delta T tends to 0. I'll put limit here. Okay, so this term, if I take delta T equals 0, this will be converted into dq by dt. You must have seen this term. This is the instantaneous current because we have shrink the time interval. Okay, so now we are familiar with the two concepts of a current, that is average and instantaneous current. So I'll be also giving you the question on this instantaneous current concept. Let's say I say that the charge flowing through a particular wire has an equation that is, let's say, 2t square plus 7t plus 3. Okay, and I'm saying you to find out instantaneous current, or they can like simply say find current at t equals 3 seconds. So you have to do nothing. You already know that the question is asking for current at an instant because it is not giving time interval, it is giving time instant. Okay, so for that particular thing, what you will have to do is you have to differentiate. You already know this formula, and put time equals 3. So if I differentiate this particular term, I'll get 4t plus 7. Now I'll have to put the t as 3. So if I put T as 3, that will be 4 into 3 plus 7, that is 12 plus 7, that will be 19 ampere. This is the current at an instant. Okay. From this same question, we can also find out the other term, that is the charge flown. Suppose I take a question that the current equation given, let's say 3t square plus 4t plus 1 is the current equation given, and we have to find out the net charge flown through, let's say this is the wire. We have to find out the net charge flown or delta T flown through wire in span of time, that is from t equals 0 to t equals 3 seconds. So how will we do this thing? We already know this formula, that this dq dt, dq by dt. So I have got this as and my equation, or given the equation of this particular term. So what I'll do it, as I know the differentiation and integration concept, I'll take dq equals I dt and integrate it. Integration of this thing will give me delta q, that is the charge flown through this span, that is t equals 0 to t equals 3 seconds. What is the equation of I? I is 3t square 4t plus 1. And let's integrate it with respect to t, and time interval is from 0 to 3. So if I integrate it, that will give me t cube plus 2t plus t, and I'll put the limit. I think you are like familiar with the concept of putting limits, so I'm just directly doing it. If I put the limits as 3, that will be 27 plus 6 plus 3. If I put the 0, it will give me 0 only. So that is 33 plus 6, 36 coulomb will be the net charge flown through this wire in the given interval of time. Okay, so this concept can be useful to find out various things like current and charge, maybe at an instant and maybe at a over a period of time. Okay, so this was about current. So now we will be studying about the other concepts of the current electricity. Okay, so before doing anything, let me make you familiar with the concept of how current comes into existence. See, there are two situations. First, let's say if we take a conductor like this, I'm assuming a very uniform and symmetric conductor, but it can be random. If we take a conductor like this, we have two conditions. First, when no potential difference is being applied. Okay, when no potential difference is being applied. And second concept is when potential difference is applied across ends of conductor. Okay, so let us take the case first when no potential difference applied. No potential difference applied or no voltage applied. Okay, so in this case, since there is no voltage, so the motion of electrons in this conductor, since electrons are already present inside a conductor, that will lead to the flow of charge. They will, if I look at the motion of a particular electron only, then it will be random like this. And if I take it over a period of time, the average velocity and average displacement of this particular electron will be 0. So this random motion of electron is known as Brownian motion. Okay, so this is known as Brownian motion. So when we have this motion, like the average velocity or the magnitude of average velocity is 0. because there is no net displacement or no net shift. As you have seen here, the electron was moving, and like after random motions it is already at the same position. And also the drift, or I would say the displacement, is also 0. Okay, but I would say the speed is not 0. In fact, it is of the high order, that is of the order 10 raised to the power 4 to 10 raised to the 5. Okay, why this is speed is so high? Because like the speed is high because it is speed that is resulting from thermal agitation. Okay, that is the heat already present in the surrounding. Okay, so like I'll be making you familiar with other concepts in this chapter also. So for now I'll say that this Brownian motion is a result from the thermal agitation or the temperature difference. Okay.